Hello, good day, good morning, and good afternoon, everybody. Thank you for joining today's webinar with Selco's Global Mycotoxin Review. Today we will be looking at the 2024 data and the outlook for 2025. My name is Marcella, I will be your host for today, and before I will introduce the speakers to you, I have a few small announcements I would like to make today's session a success. First of all, we are recording today's session, so don't worry if things move a little fast for you or if you have to step out at any time. We are recording and we will be sharing the recording with you afterwards. Second of all, we are a very large group of attendees today, so we cannot have you speak up in your microphone. However, we do want to make the session as interactive as possible. Therefore, we would love to get your questions during the live session, so I can ask it to my speakers that are waiting for you. So those are my two little remarks that I wanted to give to you before we start today's session. And let me introduce our speakers for today. There they are. Right next to me, we have Dr. Swami Haladi.
Hi, Marcel.
Hi, Swami. Dr. Swami is the Technical Commercial Manager for Selco's Mycotoxin Risk Management Program, and he oversees our global presence with our mycotoxin mitigation solutions. Really great to have you.
Thank you. Thank you so much.
And next to Dr. Swami, we have Mr. Avinash Bhatt.
Hello.
Nice to have you here. Thank you. Mr. Avinash is our mycotoxin specialist at Master Lab, and he will be sharing really in-depth information on the data that we have gathered over the last year. And so, yeah, really great to have you both. Before we kick off, Dr. Swami, it's so great to have you. And for those of you who have been joining us for the past years, this is actually our fifth time, if I recall correctly. Sixth time even, yes, wow. So we keep coming back every year, and every year I ask me the same question. Why is it so important that we keep doing this review?
Well, I think it's very relevant, Marcel, because every year the things don't remain the same in the world of mycotoxins because these are all natural toxins, and their occurrence very much depends upon the weather conditions, and also the trade of grains from different parts of the world also makes it more complicated. So it's important to review what happened in the last year. And I think what is really we're adding a new dimension to it is what Avinash is going to talk a little bit in detail, is using the historical data, how can we predict the mycotoxins in the coming months. Yeah. So I think that's a very important tool for us.
That is very important because I think for the viewers who were with us last year, they got the premiere of our prediction models, at which time I think we could only predict one. But Mr. Avinash, you have some great news with us to share, I believe.
Yeah, this definitely, because I'm very excited to share the details. So
I believe we can even now share some information on the big six, right? If I'm correct?
Yes, so we can predict the big six. So that's possible now.
So we're really looking forward to your in-depth content on that prediction models. So just to remind everybody who is joining just as we are having this introduction, we are recording today's session and we will be sharing the recording with you as well. And next to that, we are really looking forward to have your questions. So if you have any specific questions about your region or about any risks that you are worried about, please enter your questions and we will be able to answer them throughout the webinar. If we do have a lot of your questions and we run out of time, we are very happy to stay a few minutes longer for those people who want to ask their really pressing questions. However, we do aim, of course, to close at our designated time of 1 hour duration. So without further ado, I wish you all a lot of fun and a lot of learning as well. And I would like to welcome Dr. Swami to start his presentation.
Thank you. Thank you, Marcel. Thank you. The content about the mycotoxin review, it's as usual, the objectives of doing this webinar is for us to understand the challenges we are facing in the 2024 mycotoxin analysis, and of course moving that to see how those data we have generated over the last year, or even in fact this year we have gone back to 5-6 years and see how that can help us to predict the data as I mentioned earlier. So what are the main objectives for us today? So one is the global and regional outlook of mycotoxin contamination. That means we have analyzed the entire data set, irrespective of the feed samples or raw materials, and you will get a nice overview of the global contamination, and then we go by regions. So whether, for example, Asia Pacific region, European region, Latin America. So we give an overview of the regional contamination, because that's also very, very important. Yeah, of course, we give the details of which raw materials face the greater threat of which particular mycotoxin in 2024, and how does contaminated raw materials can end up having those mycotoxins in the complete feed, because we are in the feed industry. That's very, very important for us. What happens after feeding these contaminated feed to the animals, and how that impact their health and performance, and of course, end of the day, is economic returns to the farmers. And then what can we learn from this profile? So unfortunately, due to the lack of time, I cannot spend a lot on the management side of it. But of course, there are some techniques I will briefly mention at the end to manage the risk we have in front of us. And Avinash, as I mentioned before, will come back to us in a little bit more details about at least using at the moment the prediction models, the statistical models, to predict the mycotoxin levels that may be coming in the coming years. This is my regular slide. I think it's just to give an overview, because in the audience, some people may not have a good understanding of mycotoxins. So today, scientists have discovered more than 600 mycotoxins. Of course, it's impossible to analyze all these mycotoxins at the commercial feed mill level, at the integrator level, because it's quite expensive, it's time consuming. So that's why the industry will look at measuring those 6 mycotoxins as markers for mycotoxin contamination. Those include deoxynivalenol, we also call it as DON, T2 toxin, zearalenone, fumonisin, aflatoxins, and ochratoxins. And you will also see that in various literatures nowadays, a lot of new emerging mycotoxins, especially eniatins, are becoming a significant impact in the animal industry, especially in the swine industry. So those should come up. If you ask me, there is a lot of need for the analytical companies to come up with rapid methodologies for analyzing these new emerging mycotoxins, and also masked mycotoxins such as the 3-DON glucoside. So where do we get this data? Basically, we have installed a number of mycotoxin analytical equipments around the world. Those include the lateral flow based methods, include HPLC, LCMS-MS. So these instruments we have installed different parts of the world at customer level as well as at our own laboratories. And these provide us the data to present to you the overview for the year, and potentially the prediction for the coming year. And we also use this data to develop our digital tools such as Mycotoxin Monitor, which we relaunched recently, and also the Mycotoxin Advisor. So it's a very, very important part of the feed mill at an integration level, looking at the feed and raw material supply, the production of feed, quality control, and based on those feed formulations with the nutrition aids, and how having the good knowledge of mycotoxins in the raw materials in the feed helps in having a better better formula and also better performance. Some basic information as you go through a lot of quite a few slides. So we have. I just want to make you understand that when we mean the percentage of contamination, remember that we are only mentioning to you out of 100 samples, how many of those samples are contaminated with mycotoxins at the levels that are above the limit of detection. So we just detect them. So the percentage contamination includes those. Whereas concentrations of mycotoxins, which you will see in ppb in our presentations, is more about how many micrograms of those toxins are present in a kg of the feed or the raw materials, and that has to be above the limit of quantification, because we really need to be able to quantify those toxins. So those are the main two differences you will see as we go through. Of course, parts per ppb is parts per billion, and then we have divided, because we have so many raw materials being analyzed, so many feeds are analyzed. So just to give you a little bit of a clear understanding, we have divided those raw materials into grains, grain byproducts, protein meals, so that it's easier for you to follow up. So when we look at the data, as I said earlier, we are at the moment focusing on the big six toxins, because at the feed mill, those are the toxins being analyzed today. However, we need to evolve, come up with new mycotoxins, in the coming years, to be able to do at the feed mills, not under the research facility, but at the feed mills. So we have more than 85,000 samples. The 47 countries are represented here. Raw materials constituted around 65% of the total data set. The complete feeds 35% of the data set. So here again, very important part is that we are able to analyze various different feed samples, which is very, very important for nutritionists and veterinarians to see what is the impact of these contaminated feeds on the animal health and performance. So those are the countries. I don't have to go through in detail, but you can see the major countries are represented there. In North America, Canada, Mexico, USA, especially Canada and USA, they export quite a bit of raw materials across the world. We have Brazil in there. We have China, India as well. So countries which are using their own local raw materials, plus the countries that are exporting the raw materials for various countries. If you look at the data analysis by the sample group, the feeds were closely about 35% of the total data set, as I mentioned before. Then the grains, number 2 position, grain byproducts. Every year, the analysis of grain byproducts is increasing, as you can see there. And silages, interestingly, some of the markets, where we are operating, quite big in the dairy industry. So the number of analysis and the silage samples are also increasing. Protein meals, TMR, the total mixed ration for ruminant animals. And of course, as usual, there are some unspecified samples, which we always emphasize to the people who are sending the sample to us, to make sure that they are naming the samples properly, so that we can categorize them into the right group and actually increase the prediction opportunities. These are the sample details. I will not go through in detail, but you can see grains, the majority of them are maize, wheat. Of course, those are the raw materials used around the world. We have barley as well, which is being used more and more nowadays, especially in Europe. Protein meals, soybean meal, maize gluten meal, and the byproducts, maize related and wheat byproducts are quite common, and lots of feed samples, including the pet food, aqua feed. You can see there quite a few of those samples. So first, let me look at the mycotoxin contamination of the entire data set, irrespective of the type of samples. So what did we see in 2024 is that again, zearalenone contamination came out on top. That 66% of the samples that are analyzed had zearalenone in there, followed by DON, and then the T2 and fumonisin. So this is nothing new for us, but what is really interesting for me is zearalenone contamination coming on top again. And that is something, put me a question, is that only a field mycotoxin, or can it grow during the storage as well? So, changing climatic conditions may be influencing that as well. We tend to see more DON contamination, more fumonisin contamination, but in the last couple of years, we are seeing zearalenone and T2 contamination is going up as well. The average concentrations were, of course, fumonisin was around 900 parts per billion across the globe, across the samples, and then followed by DON, and those levels certainly can be concern to some of the species of animals, if not all the animals. And then the median concentrations, which we emphasize quite a bit, is, I think, a better representation due to the ability to remove some of the outliers, which you can see, for example, down, we had one sample with 500 ppm, right? So it's quite a high level. So one sample like that can skew the data. So overall, apart from the zearalenone showing up as a major contaminant based on the percentage of samples we analyzed, but still the 82 ppb of zearalenone can be a concern to some of the species, especially the swine and dairy cows. So that the data we are presenting here more in the pictorial way, setting up the data there. On the left-hand side, you see the percentage contamination I explained already. On the right side, instead of only mentioning the outage, you can also see in the box plotter there, where you can see not only the information on outage, which is in the diamond shape there, but also the median, how many outliers are there. And you can see one good example I can give you there is look at ochratoxin. And the ochratoxin, the average, which is in the diamond shape there, which is outside the box, indicating that there is a lot of variation between the samples when it comes to the ochratoxin analysis. And when you move to the right side, as an example, you look at DAWN. Yes, the average concentration, that diamond shape there, is actually more closer to the median. That means between the samples, there is a less variation for DAWN. Of course, you see one outlier up there, 500 ppm. That can also explain the reason, the importance of providing the median information along with the average concentrations. So, and the trends, providing the trends, the global trends also helps us to see the impact of the weather conditions or impact of combination of different raw materials depending on the different parts of the world. You can see for aflatoxin, there's a varying trend over the months, and somewhere in the month of August, October, peaking. And the same thing you can see for ochratoxins. And you can ask me the question, why aflatoxin and ochratoxin are showing a similar trend? Because although aflatoxin can be produced in the field and ochratoxin can be produced in the field as well in small grains like wheat, barley, but we see these two toxins majority as a storage mycotoxin. That is why you can see a very similar trend between the aflatoxin and ochratoxin. And then you see the DAWN and zearalenone. To the right of the DAWN, you can see a very similar trend. Again, it gives us, the concentrations are different because if you look at the y-axis, the numbers there are not exactly the same, right? So of course, DAWN is at a much higher concentration as compared to zearalenone, but you see the trend is very similar because both the toxins are produced by the same Fusarium graminearum, predominantly the fungus in the cooler climatic conditions. So very good information available in terms of the trends. Then fumonisin is a bit different trend because it's altogether a different Fusarium fungus that produces fumonisins, which needs a higher temperature and also a bit of a dry conditions are required for the production of fumonisins. And the T2 altogether a different profile. I think you can see a little bit of similar to the aflatoxin and ochratoxin in there, and that can explain. Again, T2 is another Fusarium fungus. It's not the fungus that produces fumonisin and DAWN and zearalenone. So you have to see these changes as we go through. Based on the kind of fungus we are dealing with, the kind of toxin profile also changes. Then the regional trends are, of course, aflatoxin. If you look at there, within the Middle East and Africa, it's different because I showed you before. And why it is different, you can ask me the question. Because these regions, MIA, they import a lot of raw materials from the rest of the world. So it's not really giving a picture of what's happening in their own countries, but samples are coming from USA, from Brazil, Argentina, and depending upon when they are going to use those raw materials. Remember, here the analysis is done as and when the customers are sending the samples to us, whether it's feed samples or raw materials. So they may have been stored for a while, so it doesn't really reflect the very clear trends in those regions. And yeah, so that can explain the changes as you see in the next slides. For Asia, the profile is different because Asia is capable of producing majority of the raw materials. Just not all countries, but at least China and India can produce quite a bit of their own raw materials, whereas the rest of the countries, they do import from other regions. So the trend, we cannot expect to be the same because of imports into Vietnam, imports into countries like Philippines, Thailand, that can happen as well. Europe, interestingly, you can see an aflatoxin. It's a flat line. You can see why, because of the aflatoxin levels are usually low. But I know this year in Europe, in some parts of Europe, the aflatoxin levels are high. So that is why you can see within a narrow limit of 1.8 to 2.3 ppb, you can see a similar trend throughout the year. And then Dawn, all other pictures are quite different. Even Zeralanon, to some extent, you can see that that's not exactly like Dawn. So it all depends upon the use of raw materials, when they're using, how long they've been stored. All these influences the trend what we are going to see. So to really get a trend of the harvest, we really need to pick those samples from the field immediately after harvest and try to come up with the trend that is appropriate to that region. LATAM region, a major supplier of raw materials, especially Brazil, Argentina. Again, there the trend is for aflatoxin and okra looks very similar to the global trend, but for Zeralanon, it's quite a bit of a different trend for the reasons I explained. So I think these are the things we need to be careful because you are not just depending upon your own raw materials. So you are depending on the rest of the world certain times, and that you need to be aware of the challenges that are there in US, that are there in Brazil, that are there in Argentina when you are formulating your diets in your country. North America, again a different trend there for fumonisin. That is interestingly, some of the samples we have analyzed in Canada also showing up fumonisin. Usually fumonisin should not be a major challenge in Canada due to the climatic conditions. So they are coming up now. Is it because of the climate change, or some of these raw materials might have come from other parts of the region, especially maybe from the southern part of the US? So now let's look at the raw materials. Of course, I don't have time to go through all the raw materials. We will be very, very happy to come back to you if you have any specific questions on specific raw materials. We can provide you that information. But looking at as a group, the grains as such, in terms of the percentage contamination in the top line, you can see there oats particularly, to my surprise, tend to have a lot of T2 toxin. I think this is coming especially from Europe. We are seeing the trend. And I was mentioning to you in oats, the new toxin that comes into picture, barley and oats, is also eniatins. Can that be a concern? That is something we need to evaluate. Of course, you will see the maize, the fumonisin levels are quite high, and then of course the Dawn is present in the oats as well. So this gives us an idea, not just only our conventional raw materials like maize, but also other small grains, the contamination can be expected. And below, you can see again in the terms of the concentrations, fumonisin tend to be a major challenge in the maize, as we all know. Looking at the grain byproducts, maybe if you compare the bars from the grains to the byproducts, of course the byproducts contamination level is higher because of the high fiber content. They tend to have more mycotoxins accumulated in the fiber portion. So that's why you see higher contamination. Again, especially raw materials like corn cob mix, which is used as a carrier in premixes sometimes, also can show high levels of contamination with mycotoxins. Again, depending on the raw material, it's mainly Dawn or fumonisin that show up in these byproducts. Protein meals, we have analyzed quite a few samples like cottonseed meal, groundnut, soybean meal, and you can see there, as expected, aflatoxin, quite a high contamination with in the groundnut meal, and then of course with the maize gluten meal, we can see the fumonisin, DON, zearalenone, all the three toxins showing up higher contamination. And below, if you look at the concentrations, again the fumonisin in the maize gluten meal coming at a higher concentrations. So very similar trend, but I think the main thing what we are doing is including as many unconventional raw materials as possible into our analysis. Mycotoxin trends in maize, which you know that 50 to 60% of our diets, especially monogastric, are made of maize. So we can see a kind of a trend there, especially if you're looking at DON and Zea, very similar trend as I explained, because maize is the major source of DON and Zea for mycotoxins in the complete feed. Latin America, the reason I am mentioning them because we do import some raw materials, so it's nice to see the trend, what months we are seeing, what kind of toxins there. That gives you an idea in terms of your import opportunities. North America, again, understanding, especially from US and Canada, what kind of raw materials are there and what kind of trends will also help us in making the purchase decisions. So in terms of the feeds, which is for me as a veterinarian, that's very, very important, right? Because we are going to feed those feeds to the animals, they get exposed, and that will affect their health and performance. So when you look at the feeds outlook, I'm presenting here, for example, broiler feed and layer feed together. And you can very clearly see some of the toxins are actually, the trend is higher for broiler feed, and some toxins, the layer feed, as a greater trend. It's because of the kind of raw materials we use. So I would say in broiler feed for aflatoxin, ochratoxin, and also the fumonisins are higher concentrations, maybe because of the amount of corn we use in those feeds. And the layer feed, as you all know, that a lot of other ingredients are there which can actually changes the kind of trends we see. So we have developed the practical guidance values, and of course some of you are already aware of that. And based on the actual concentrations, what we are shown you in the previous picture, and comparing with these practical guidance values we have developed, we can develop the mycotoxin risk. So that means what percentage of those feeds, what we have analyzed, broiler feed or a layer feed, is contaminated with mycotoxins, not only contamination, but also how they can affect the performance. Are they going to cause low toxicity, medium toxicity, or high toxicity? Those are indicated here. So a very similar pattern we are seeing between the broilers and layers. For the swine feeds, we have three different feed types here: the fattening feed, grower finisher feed also we call that, piglet feed, and sow feed. And these you can see the trend again, the grower finisher, the fattening feed has got higher levels of contamination pretty much across the mycotoxins. That means, generally grower finisher feed is a bit neglected in terms of managing the risk, if I have to say. So definitely that is not something we need to do. They can be toxic as well to the growing animals. We need to keep an eye on those in addition to the piglet feed and the sow feed. And again, you can see the risk there is across all the three different subspecies is quite kind of similar. So it's important that for us to achieve a maximum efficiency in the swine production, we need to look at all the three different stages in managing mycotoxin risk, not just the one stage. In ruminant feeds, we are getting, as I said, more and more samples in the last few years. Silages and TMR I am presenting here. And I think you can see a very general trend that usually the mycotoxins in silage are higher than the TMR. So this is very, very important for dairy farmers, because only analyzing the concentrates in ruminant concentrate, we call concentrate feed, is not good enough because silages contribute much higher levels of mycotoxin into the TMR. So having that knowledge is very, very critical. And the risk for distribution of mycotoxin risk ruminants, you can see it here, is quite clear both for the cows and dairy cows. And then the aquatic animals, especially the shrimp and fish, they're quite sensitive. And there is a lack of research in this area. So we are also trying to do more research in this, especially in the shrimp area. And with looking at the information available, they're very sensitive to the mycotoxins because they are not, their systems, especially the digestive and detoxification systems, are not well developed. So this is the risk for dogs, pet foods, again, very, very important. Zearalenone seems to be a major challenge, especially in the reproducing animals in canines, and of course other mycotoxins also critical. So with that, I hope we got a good understanding, Marcel, on the forecast on the mycotoxin contamination in complete feeds, also raw materials, and the risk they're posing.
Thank you. Yeah, for me it's very interesting. I think this is the first time where you are showing the comparison between the different feeds, if I'm correct.
Yeah, kind of in more detail. You're right. So because sometimes that helps in making the decisions, where they are doing good job, where they are not doing good job, and for me, being a vet, I know that the mycotoxin exposure is chronic. It happens over a period of time. Yeah. So we need to keep an eye on all the stages of animal production.
Exactly, and I can imagine if you make different types of feed, it depends which species you are or which life stage you are producing for, what mycotoxins to take into account.
When because the raw materials are also can vary in different subspecies.
As your formulation differs. Yes, I can imagine. And we are getting a few questions just to remind our viewers today. Again, we are recording, so we will be sharing it with you, and you are able to ask questions. And I see some nice questions coming in as well. One was related whether we could give any ppb thresholds for each of the big 6 that are associated with clinical signs in dairy cows. Quite a specific questions. I think it's related to your safety, to your values, right?
It's there. I didn't show because of the time. We have the practical guidance for dairy cows as well, the low, medium, and high toxicity. Yeah. And the clinical symptoms is another interesting area. Because sometimes, you will not see those levels to really cause the clinical symptoms in cows, but other factors also influences leading to clinical signs. High levels of toxins, sometimes, especially zearalenone, I would say, can cause those clinical symptoms. But most of the other toxins affect more at the efficiency, the feed efficiency level, the rumen function.
So it's not always so clear that the issue that you're having is related to mycotoxins. Exactly. It can be different things. Yes. I have another question coming in that's just simply asking how to overcome mycotoxins in feed.
Overcome is not possible.
No.
That's very clear. So because these are all natural toxins, right? These are not man-made toxins. That means they are going to be there, right? So how do we adapt our agriculture practices? Because today I'm seeing all the agriculture practices are coming in the last 10 years, 15 years, are actually making the mycotoxin area more worse than what we were before, because we are not doing tilling, we are not doing crop rotation.
Right.
So yes, right from the field, when you seed your grains, and all the way to the animal, there are different stages. Yeah.
Like you mentioned, some are field born, some develop in storage, so it's kind of impossible to really overcome.
Absolutely. Overcome probably is not possible, but of course, impact we can reduce. Yes.
We need to live with it and mitigate as best we can.
As best as we can, yes.
A lot of questions coming in, so that's really great to see. Actually, one here that is interesting that's asking what are the specific components in animal feeds that impact the mycotoxin risk so vastly. I can imagine it's related to your formulation and which main ingredient you're using.
I think maize seems to be the major one across the world, because maize, you can have DON, you can have zearalenone, you can have fimonosins and aflatoxins as well. So definitely maize and maize byproducts are the number one. and then followed by the wheat and the wheat products, because they are also quite susceptible to a lot of Fusarium fungus. And then the protein meals comes into picture. And protein meals, I tend to see more ochratoxin, aflatoxin, T2, those kind of toxins we are seeing. And small grains nowadays, as like barley, oats, they are having ochratoxin, eniatins, and new emerging mycotoxins are also coming in there.
Yeah.
So yeah, it does change depending upon the fungus.
Right.
It's like us.
Yeah.
What kind of food, I might like spicy food and you may not like spicy food. The same way, the Fusarium fungus likes some certain conditions.
Different types of material.
Types of
right.
food, right? And whereas Aspergillus likes something else. Right? So it's complex.
Very complex, yeah. And also some questions on more on how to overcome that, how to mitigate. But for now, I will park those questions because we have one more speaker lined up for you. I would like to welcome Mr. Avinash to our table to join Dr. Swami, and he will now continue to present more about our prediction models and the in-depth of the data. But for sure, we will come back to some of your questions. Keep them coming and enjoy the rest of the presentation.
Hello once again. Before starting, I would like to have an overlook of the previous mycotoxin contamination since 2020 for the last from 2022 to 2024. That's the last 5 years. So you see here a definite some sort of a patterning. You see over the years you see the patterns like waves, so like a wave pattern and up and downs. So and also one pattern you see in the fumarisin in the middle, that's keep on going. So in most of the other places, you are seeing the wave pattern. So that means there is some common trend is there. So using these trends, can we predict? Yes. So of course, so that has been there for other models. So that's been now developed. We are developing different type of models. So and also it is now possible to predict a model. Okay, so based on this one, so we are going to make a forecasting. So what is mycotoxin forecasting? So it aims in the prediction of the likelihood of the mycotoxin contamination in upcoming crop or even whatever the already produced grains. So this is it help in the information and also make a decisions in the crop management and harvesting. It also proactive measures based on the forecasts that can be more cost effective than reactive measures in the already contaminations occurred. By minimizing the mycotoxin contamination, so forecasting helps to protect the animal health. So this is why this is mycotoxin forecasting is very important. So there are several methods of mycotoxin forecasting. So first one is the weather-based models. Second one is a crop growth model. Third one is a statistical model. And the last one is a machine learning model. So weather-based forecasting that mainly aims on the weather pattern. So knowing the weather pattern, so you can predict, okay, there's a possibility of the growing of the molds. From the growth of the molds, you can also predict the possibility of the mycotoxin contamination. So second one is a crop growth. So this is mainly based on the pathogenicity in the crops, and that depends on the crop growth stages, also environmental conditions. So based on those conditions, so a crop growth model has been developed. So third one is a statistical model. So the statistical model mainly uses the data, historical data, on mycotoxin contamination and environmental factors. So that is also being used, adding to the older data or historical data, and so make a prediction on the statistical on the contamination. So third one is a machine learning. It uses all three earlier models put together, making a much more complex learning procedure in a computer modeling. That is machine learning. So next one, based on these models, so we have developed, we have seen earlier, already we have mentioned, in last year we made an attempt to predict the mycotoxin contamination, particularly for aflatoxin. So we have validated the procedure, and also much more. Also, we made further improvement in the model. So based on that one, so we again proposed. So this is extending the model into the other 5 mycotoxins. So this is how the model is actually developed. So this model was developed based on the historical data, historical average, total average data, and based on that one, we can able to predict the next what will happen in 2025. So this is the basic model for 2025. This is a pictorial view. So next one, so okay, now it's forecasting is coming. This is for the global analysis. So you see here aflatoxin. For aflatoxin, I am just putting only for the Q1 prediction. So this is here for January. For aflatoxin, you see here, so forecasting will be around 9.7 ppb with the lowest and highest, that's a 80% confidence interval of 6.4 into 13 point. This is now the accuracy, good accuracy what we are able to achieve. With a lower accuracy, there is a 95% level. So that will have 4.6 to 14.9 ppb in the January. And it's going to coming down because aflatoxin is going to come down from 9.7 to 8 ppb. That's what the general trend now is showing. So similarly, aquatoxin also, it's slightly going to increase in the next 3 months. So similarly, so we are also finding the DON contamination also going to come down from 668 to 620 ppb. Whereas also the fumonisin contamination is also going to come down. So this is actually overall trend. Similarly, you can see the trend in zearalenone and also for the T2 toxin. So that is in the T2 toxin slightly is going to increase. That is what the global trend says. So next one, I'm just concentrating on the regional contamination for Asia. So here, I'm just only giving you this only for 3 mycotoxins, aflatoxin, aquatoxin, and fumonisin, because these toxins are extensively analyzed in this region. So that's why actually I have enough data to make a prediction for these mycotoxins. So in January, of course, this aflatoxin is going to be a little bit of a decreasing trend in the coming months. It's just very similar to aquatoxin. Whereas fumonisin also, it is going to be the similar actually coming down actually in the lowering the trend, because from January it will be around 1175 ppb to 1145. Is the slight downward trend. That's what we are going to expect in Asian region. In Africa, so this is also in mycotoxins, particularly aflatoxin is going to be a slightly also showing a downward trend, whereas DON, so there is a actually a drastic downing trend in particularly DON, whereas zearalenone is going to be slightly increase in the contamination. That is what for Middle East, Africa and Middle East, the trend. So let us now consider to the European region. So this is, I could make a trend for 5 mycotoxins except aquatoxin, because aquatoxin contamination is slightly, so very, very low in terms of that one. That's why actually I did not made an attempt to for the aquatoxin. This is the trend for Europe. So here, aflatoxin, of course, slightly there will be a slight increase in the contamination level may be expected. That is from 1.5 ppb to 2 ppb. It's a slight, still it will be within the range. Then in terms of DON, so you are going to be a slight downward trend, and zearalenone is also a slightly increasing trend. And fumonisin almost it will be a flat trend. So, and T2 toxin also going to show a downward trend from almost 20 ppb to 13.5 ppb. So this is about the trend. So thank you.
Thank you. Let me just wait until I appear again in the screen. Yes, there I am. Hi, everybody. Thank you, Mr. Avinash, for your presentation. I have some questions for you, but we will address those once Swami finishes our session for today. So please stay tuned and keep adding your questions, and I'll leave it to you, Dr. Swami, to give your recommendations.
Thank you. Thank you, Marcel. I again. Of course, basically, I think from my presentation, as well as with the prediction models from Avinash, it's very clear that the trend is there in the mycotoxin contamination. And of course, we are only presenting 6 mycotoxins, and that's my recommendation to those people who are involved in analytical to come up with more and more rapid methods for detection of some of the emerging mycotoxins as well, which will help us to see more integrated approach to the mycotoxin risk management. Because I could say in recent times we are seeing quite a bit interaction between DON and eniatins, just as an example, right? So we really need to move forward with more simpler tools for the diagnosis of some of these emerging mycotoxins, if not for all. I know it's not going to happen for everything because we have more than 600 mycotoxins. So with this kind of a combination of toxins, what we are seeing is certainly, some questions were asked about the management tools. So of course, there are a lot of management tools that will take another 2 hours for my presentation. Certainly, we will come back later on with some of the webinars to focusing on the solutions, an integrated approach right from the crops, sown on all the way up to the managing the risk in animals. But meanwhile, of course, as a company, we are looking at the new mycotoxins coming in, the existing mycotoxins. We're really very clear that we need to have different modes of actions to manage our mycotoxin risk we have today. And that's why we emphasize not just only on mycotoxin binding approach, but also how can we improve the health and performance of animals through improving the gut health, which is affected by mycotoxins. Of course, there are quite a bit of those toxins which can do that. And there are many mycotoxins, pretty much all the mycotoxins can impact the immune system. So how can we strengthen the resilience of these animals to manage the immune system when they are under the threat of mycotoxins? And then, of course, antioxidant status, also very, very important for some of these toxins, especially in the reproducing animals like sows and dairy cows. So we are looking at a very holistic approach for mycotoxin risk management, not only in the product development but also in the overall management and advising our farmers, advising our feed millers what are the best practices. And that's very, very important for us. With that, I would like to conclude, giving us some time for question and answers, is that the more than 85,000 mycotoxin analysis what we have done showed contamination range between 24 and 66. 66 being zearalenone, 24 I believe is ochratoxin. So you can see the trend. Some toxins contamination is going up, some are going down, and that's why I think we need to add more mycotoxins into this pool at the feed mill levels, so that we know what's the kind of trend. And then, of course, we look at in the region-wise, aflatoxin in terms of the percentage of contamination of Asia and Middle East, Africa will always be the front runner because of the climatic conditions existing there. While zearalenone, expected cooler climate, Europe, North America, higher trend. Fumonisin is a major trend in Latin America. That is something a big concern. Because when you are importing raw materials in that parts of the world, we need to keep an eye on the fumonisin levels. And then as concentrations, which is very, very important for understanding the toxicity within the animals, then of course the concentrations, we have a very clear trend. that usually fumonisin are always at higher concentrations, followed by DON, ZR, T2, aflatoxin, and ochratoxin. And this trend remains the same. But also remember that it's, not necessarily the DON can be more toxic to animal as compared to ochratoxin, which is present at the lowest concentrations. Because in some species, in poultry especially, ochratoxin is very, very toxic at a very low concentrations, whereas DON has to be around, I would say, 1,000 ppb or so. So don't look at the concentrations in isolation. Look at the toxin in question and the concentrations together. Then, of course, what is the impact of these concentration in the animals? You have seen that nicely, the way we're representing, depending on the species, there is a variation in the sensitivity. And you can see there, poultry used to be not a sensitive species for DON and fumonisins. And new research coming up is showing poultry is much more sensitive than what we thought, especially broiler chickens. And that's why you see that came ahead of pigs in this case. So, right? So it's really changing, and we need to keep an eye on that. And then what Avinash presented is just the beginning. More the data we get, Avinash will be able to predict more accurately for various toxins, for various regions. So more samples are very, very critical, and that's what we aim to do in the coming months and years. And then, of course, the solutions has to be multifaceted because the challenge itself is quite complex one. So with that, I would also like to acknowledge quite a few people from our group, because Trans Nutrition is a big group with a lot of people involved. From Master Lab, my colleagues Martin's his support, and also Mark in terms of the analysis. We want to also acknowledge the Director of Feed Safety, Pedro Caramona, my colleague Guanlin Wang, Pim, also for their contribution in making these projects happen. And then, of course, our colleagues at our GSS team in the digital technology, which is going to play a significant role in transforming our data into something meaningful insights to our customers and our partners. So with that, I believe for more information, you can either contact me or Marcel, or going to our transnutrition.com website. So with that, we are open for question and answer.
Thank you so much. Yes, let's welcome Mr. Avinash back into the back into the picture. If you could move a little closer, yes, then we can see both of you in the screen. So thank you both so much for your presentations today. Very nice insights, and actually quite some new things that we are showing today. So it's great to see that every year we are evolving and we are improving our data and the way we are able now to start predicting even. So like I mentioned, a lot of questions are coming in, so keep them coming for sure. Starting with you, Dr. Swami, there was a question related to dairy before. We have
Sure.
another one related to dairy.
Okay.
Could you elaborate a little bit on what are the clinical signs of mycotoxin contamination in dairy cows?
Sure. The dairy cows, actually, there is one area which, of course, again, going back to the rapid analysis, there are a lot of mycotoxins in silages, you saw there. And even if you have the capability to analyze rapidly more important mycotoxins, especially the penicillium mycotoxins in silages like Rhacofortin C, mycophenolic acid, some of these, I think you will see more mycotoxins coming out of that, right? Mm-hmm. So these are the toxins which have a significant impact on the rumen fermentation.
Okay.
Right? That means if your rumen fermentation is affected, the feed is not digested properly, you see a lot of undigested feed particles in the feces. And of course that impacts the somatic cell counts in the milk because of the stress involved with the mycotoxins. So, and then of course Zeralanar is something a very, very classical reproductive, it can cause reproductive disorders like retention of placenta, in a very high levels, of course, abortions. But we need
That's when it really gets extreme, right?
Extremely high levels,
Yeah,
yes,
yeah.
indeed. And then we have to look at the, differentiation of various causes, right? Mm-hmm. Because the abortion can cause by a number of reasons.
Yeah.
So of course, mycotoxin zaralandan is one of those, and ergotoxins are also quite significant ones in dairy cows. So, but always we need to look at the differential diagnosis. Is it a disease, or is it a feed, or a management issue? So, yeah. So dairy cows, I think we are getting more data. Hopefully we can give more information in the coming years.
So would you then advise to, because like you mentioned, it doesn't always have to be mycotoxins when you start seeing clinical signs.
Yeah.
So would you suggest to then test feed samples or feces samples, blood samples, milk samples? What would be the best approach to come to that diagnosis?
At the moment, of course, more confirmatory methods are being evaluated. But I think what is practical today is more on the mycotoxin analysis in the TMR.
Yeah.
Of course, we do have a challenge of analysis of TMR because of the high fiber content. But I think there are techniques available which are validated to do that today. So yes, a TMR analysis is important if you are seeing symptoms, not your silage, not your concentrate, because you are feeding the total TMR.
Yeah.
But of course, then if you come to know that, in my example, you saw a lot of mycotoxins coming from silage, right?
Yeah.
So then you follow that silage and see what's the quality.
Kind of narrow it down from there. Yeah. So a question for you, Mr. Avinash. You were predicting for Q1.
Yeah.
What is the reason why we are not predicting for longer periods?
This is a good question. So you might have seen in the weather forecasting, just because it's very, very common. Everybody normally sees, okay, tomorrow what's happening. So normally weather forecasting gives you maybe 10 days in advance. But if you look at every day, then it will keep on changing. Right. The forecasting will not be constant, so it will keep on improvising. So I can give you 1 year, a prediction, but so that's it's not going to be correct. So that's why actually more appropriate right now, because I have seen for a 1 month data that will give you a much more better result than the 3 months. So I'm just giving you the first idea, so that 3 months, okay, this is the 1 quarter, so it will be a pretty good idea. So of course, if I add the next month data, January data, then my prediction also will.
So it evolves throughout the year, right?
Yeah.
Okay, well, that makes total sense to me. Indeed, the good comparison to the weather.
Yeah.
So the longer you look in the future,
every month.
Right?
Yeah.
Back to you, Dr. Swami. I know you briefly mentioned our toxo portfolio and the importance of going beyond binding. I'm getting a lot of questions on what are the remedies, how can we bind, are there antitoxins available? So I think I've heard you mention before, we need to go beyond the binding.
Yes, indeed. I think that's quite well known in the industry today. People agree with that concept. Innovation has to happen. Looking at new things. Of course, people have looked at enzymes, detoxification systems, right? That is something is there, and also even going, how can we affect the biotransformation systems within the animals? How can we make liver more resilient to some of these toxins, right? So, I think it's as the toxins are evolving. Right? Now we are getting to know, just as an example, I keep telling about aniatins because we are analyzing more, we know what's going on, and we know it can cause issues, right? So as we know more and more, depending upon what does it do to the animals, we need to come up with technologies, if that is a significant challenge to our industry. So it's not a kind of a blanket approach what we used to do in the past. Of course, that is important. That's where I think our bentonite comes into picture. More like a blanket approach for the mycotoxins, but if there are some specific toxins, certainly we need to keep looking at how can we take care of
and this is also due to the fact that probably you will never have just one mycotoxin in your feed. It's usually a combination of low level toxins that together can have an effect, so you need to go beyond just binding the 1 or 2 or the 6.
Yes, that is why what we presented and the risk is a bit more individual toxin wise, but we know that our risk is a little higher when you start combining those. Yes.
Back to you, Mr. Avinash. There's a question coming in around the prediction of ZIA in Europe in Q1. What would be the reason for the ZIA increase in the European region in Q1? Very specific question.
Yeah, this is going to be, because it's very, very complex, because I'm seeing the pattern. So this is a model when we are developing. So it also, because Europe actually imports a lot of material from the other part of the world.
Right.
So, and also the indigenous content. So this is a combining factor, because zero known, so normally affected by the cold weather, because if it's the cold weather, but because it's a historical data says, okay, this is a common trend. So based on the trend, so this is what actually we are expecting.
Even though you would not be expecting it from the normal situation, the data really tells us another
because
story.
A trend is showing, okay, this is every time this is happening, and this may happen this time as well.
I think Marcel, this is still at very initial stages. It's a bit complex, right? Because it depends upon what kind of data we are getting in. If it becomes more local data, right, and tracing that where the sample have come from is a big question.
Right.
Right. Not for the whole industry, right? So as we put our control on that, I think we will be in a better position to be more predicting as Avinash is saying, maybe the prediction gets better. Because you know that this sample has originated in Netherlands, just as an example, but we don't know now.
No.
It might have come from some other parts, Eastern Europe, or it might have even come from US. Ireland, for example, uses a lot of raw materials from Canada. Right? So this is very much dependent upon what we are getting from the rest of the world.
Actually, quite exciting to see that we will probably be showing something new again next year then, most likely. So we keep improving there. And we really want to keep sharing it with you as well, our viewers. We came to the end of our session today. Thank you very much. Once again, you will receive the recording of the session as well. Thank you for all your questions and your interactiveness. And we really look forward to meeting you again next year for our review. Thank you very much.
Thank you so much. Appreciate your time. Thank you.